Okay, so in this video, we are going to talk about full immunization. So far we learned about dedication and reading to immunization. So under dedication, we match we match cash inflow to cash outflow. So really exact matching. So if you have liability in 5 years, then you find asset which going to have same amount of cash flow in 5 years. Under reading to immunization, you try to make your portfolio immune to small change in interest rate. To do that, you satisfy these three conditions. Basically, you set your present value of asset equal percent of liability under current interest rate, and the derivative, first derivative to zero, and the second derivative non-negative. Okay. If this happen, then portfolio mean basically asset and liability, the total portfolio. Immune to small change. So now we are going to learn about full immunization, basically for any change for any type of interest rate change. We want the portfolio to be fully immune. So the immunization technique developed in previous section is designed to work for small change in eye. Full immunization extend this technique to for any magnitude in eye. So so the idea is basically in order to work this, in order to make sure this is going to work, we need two types of assets per liability. So so this section explained that. What that means basically, if you have liability here, then you sandwich it using two assets. So basically, you sandwich each liability using two assets. If you can do that, if you can find assets like that, remember all of this you need should be able to do it. Okay, sometimes you cannot do that. You cannot find two assets like that. And then if it satisfies some requirement, then you are going to have full immunized portfolio. So we will say, so first the definition of full immunization. We say that portfolio is fully immunized if present value of assets is more than present value of liability for all positive Y's. So this is the keyword for all. The full immunization condition, what are the requirement the portfolio need to satisfy? First, present value of asset equal to present value of liability. Modified duration of asset equal modified duration of liability. You saw that under redeemed immunization actually. Then the last one is the difference. The asset cash flow occur before and after the liability cash flow. Actually, there's a mathematical proof for this. I'm not going to do that, but if you go to, if you have copy of mathematical interest theory by Leslie James and so and James W. Daniel, you can find the proof there. So they gave the proof for this fact, how that's going to happen. Because the third condition, maybe you may think, okay, how do you really mathematically prove using these three, this is going to happen. There's a mathematical proof, but we are not going to do in this class. So of course, you may wish to full immunization portfolio with multiple liabilities rather than a single one. You may adapt the strategy of selecting pair of assets to immunize each of the liabilities. So for each liability, you dedicate two assets, one before and one after. Just as was true for adding to immunization, you will need to frequently rebalance your portfolio to maintain the immunized state because the derivative condition P prime I0 will not continue to hold with passing of time. So remember that at current rate, the derivative should be positive. I mean, the cross derivative should be zero. So that may change with different rates. So so you need to make sure that it is whole so that when basically you have rebalanced the portfolio. So let's do a few examples. Take a minute and read the problem and see whether you can do it. So here it says an insurance company has committed to make payment of 100,000 in 10 years. In order to fund this liability, the company has invested this much in 5-year zero coupon bond and this much in 15-year zero coupon bond. So let's first draw the timeline and see how this looks like. So the liability is 100,000 in 10 years. Right now invested in 27,919.74 in a 5-year zero coupon bond and invested. Okay, so not the so this is basically percent value. Okay, so let me run. So if in 5 years it's going to be value X, but the percent value is 27,919.74. The same for the 15-year. The percent value equal again the same 27,919.74. The annual effective yield on all assets and liabilities is 6%. So rate I we are going to use is 6%. Determine whether company version is fully immunized. So let's first check the whether percent value of assets equal 100,000. I mean the 100,000 discounted at 6%. Okay, so percent value of liability. So that's 100,000 divided by 1.062 negative 10. And that would give you, let's see, 179. This looks like maybe the rate is not right. Let me see. So 100,000 in 10 years. So if I take the 27,919.74, so let's see, 100,000. Oh, no, not divide by. That's what we're talking. So personal liability is 1.06 to the power 10. Okay, so you get 100,000 divided by 1.06 to the 10, and that is 55,839.47769. Now the present value of assets is actually easy because it's already given. 27,019.74 plus again another 27,019.74. So if you add those values, and you get very close value. So it's going to be 55,839.48. It is very close to this value. So these two are same. So present value of assets equal present value of liability. So first condition is satisfied. Let's go to second condition. Let's take the duration. So the duration of liability, you can take the modified duration, which is easier in this case. So duration of liability is 10 because only one cash flow. And the duration of assets, so you have for the 5-year zero coupon bond, it's 5, and then you invest 27,919.74, and the total portfolio value for the assets is 27,019.74 times 2 because you have two of those. So this one and then this one because you have two of those values. Then for the 10-year bond, it's 10. The value invested is 27,019.74 divided by the total portfolio value, present value. The portfolio mean actually only the asset portfolio, not the liability. So this one give you, it's basically 5 divided by 2 plus 10 divided by 2. This should be 15. So it's 15 years. Not 10. The bond is 5 and 15. So that's give you 10. So the 10 for the duration of assets, 10 for the duration of liability. So that's condition also. The third one is you need to have assets cash flow before and after. So right away you can see it happen before and after. So this is the liability, and these are assets cash flow. Okay, so third condition also satisfied. So that means the portfolio is fully immunized. Okay, so let's do another problem and see whether we can do this. So this one says an investor has single liability of 1,000 due in 15 years time. The yield on the zero coupon bonds of any term is currently 4% per annum, and the investor possesses cash equal to the present value of this liability. That is 1,000 times 1.04 to the negative 15, which is 555.26. Let's check that one actually before we continue. Whether any error in 26 here, so it should be dot. He wished to invest in 10-year and 20-year zero coupon bond in such a way that he will make a profit on any mere change of the cost of interest. how much of each security should he buy, and how large profit will make if the rate of interest change become 0.01, 0.02, so forth. So let's see what's going to happen. Okay, so here is time 0. Due in 15 years. So this is liability. Liability due in 15 years, 1,000. Wish to buy 10 year and 20 year. So amount of invest in X and Y. So, so that would be the amount invested in 10 year for X, and 15 year for Y. I mean, the 20 year for Y. So this is amount invested. So this is the present value. Okay. So let's write the equation first. Present value of assets equal X plus Y equal 1,000 divided by 1.04 to the 15, which is given as 155.26. The second one, duration. Of course, you can see the duration of assets is X time 10 divided by X plus Y, because these are zero coupon. Y time 20 divided by X plus Y should be equal to the only one cash flow, which is in year 15. So duration is 15. So that would give us, let's use X and these equations solve X and Y. So the second equation you can see it's 10x plus 20y equal 15 times x plus y, which is 555.26. Because x plus y equal to this one. So now I'm going to replace one of these x and y using this equation, equation 1. So equation 1 says x equal 555.26 minus y. So I'm going to substitute that in here. So 10 times so that gave you like 10y equal 15 minus 10 times. So that's a 5 times 10y. So you can solve for y, and y is going to be 0.5 times. So that's going to be what? So 277. 63. From there, you can get x. You can see it's actually half of x plus y. X and y are actually same. So basically, this y also, x is also extra. Or you can use equation 1 to get x. So we know the present value of money invested on 10 and 20 years, 0.1. So the third condition, actually, whether it's fully immunized, you need to have cash inflow before and after the liability. So that's also satisfied. So cash inflow before and after liability. So that you can right away see that satisfied. So now, what would be the change if rate change from 0.01, 0.02, all of this? So let's do only one, and then the rest you can do. So let's write the price function. So price function today is, it would be what? It would be x plus y, that's asset, minus let me do this. So So what is the, so if you invest X in 10-year bond, what is the value in 10 years? So it would be under rate, it should be X time 1.04 to the 10. Okay, and then Y time 1.04 to the 10. Okay, that is what you were expecting. So now we discount. So X time 1.04 to the 10 divided by rate 1 plus I to the 10. Then Y time 1.04 to the net 10, 20, it should be 20. 1 plus I to the 20. Minus 1, this is 1000 due in the 15 years, so 1000 divide by 1 plus I to the 15. So now if rate is, let's say, so if I equal, let's say 0.01, what would happen? So I know X and Y both are same value, so I can type that. 1.01 to the 10. One thousand divided by 1.01 to 15. So let's see what would be the outcome. What would be the new price? So 277.63 times 1.04 to 10, then divide by 1.01 to 10. So this one is 372.0369. This one is 550.7055. So let's add these numbers and see the difference. So it would be $61.39. So you can see that the rate was, original rate was 4%. And then it decreased to 1%. Then you are still getting profit. And you can try what happens if it goes to 8%, the other side. Still you are you make profit. But once it goes to 8%, then your P prime I may not equal 0. So then you have rebalance your portfolio to make sure that at that point, now again it's immunized. So so here we have a few questions. Let's try one more and then I will leave the rest for you. So this one says, Akash has liability of 6,000 due in 4 years. And then liability will be met with payment of A in 2 years and B in 6 years. Akash is employing a full immunization strategy using an annual effective interest rate of 5%. Calculate A minus B. So let's try to do this. Has liability of 6,000 D in 4 years. So in 4 years, liability is 6,000. This liability will be met with payment of A in 2 years and B in 6 years. Using the full immunization. Annual rate is 5%. So basically, if I discount present value of assets, that's A divided by 1.05. Two plus B divided by 1.05 to 6 equals 6,000. Okay, that's the present value of liability. I mean, the liability is 6,000 divided by 1.05 to 4. So that would give me basically you can see 1.05 square is common factor. So I can say A plus B over 1.05 O equals 6,000. Okay. That's the one equation. The second one is derivative, I mean the duration. So these are cash flows. So the duration for the A would be 2 So if I use the macro duration, this would be 2 times A plus divide by, I mean discounted by 1.05 to the power negative 2 plus 6 times B 1.05 to the negative 6, then divide by the present value of cash flow, basically A time 1.05 to negative 2 plus B time 1.05 to negative 6. Then that should be equal to the modified duration of liability, which is basically 4. So you have two equations. So from so let's try to solve this equation. So this one will give me what? A plus. What is B divided by 1.054? So basically 1.05 to the that is 0.8227 and 6,000 divided by 1.05 square. That is 5,442.57. Then in here, so from this equation, you can see A divided by 1.05 square and B divided by 1.056 equals 6,000 divided by 1.056. So that value is what? So 6,000 divided by 1.0524 is 4,936.214849. So this value basically is that. So let me write one more line. So 2 times A 4936 equal 4. So now you can substitute A or B using one of these equations. Let's substitute for A. So A is 5442.17 minus 0.8227B. Now I'm going to substitute that in here. Then you can cross multiply this one is equal to 4 times. So now only one unknown, only B. So if you solve this one, you will get B equal 3307.50. And then again, using this equation in here, you can get A, and A would be 2721.09. So then you can get the difference. So basically, you solve for B now, only one unknown. So you solve this equation. Okay, so I'm going to stop there, and then I think you can do the remaining two problems here. And if you need help, let me know.